All right. We've seen that logarithmic functions are the inverses of exponential functions, and we've seen how we can find the inverse of an exponential function as a logarithmic function. But finding inverse trigonometric functions is slightly more involved because trigonometric functions are periodic, meaning they're not one-to-one. So we need to restrict the domains of each of these functions to get one-to-one functions that actually have inverses. Now, we've already briefly talked about how we can make those restrictions, so I want to very quickly just show you how those restrictions are and what the graphs look like for inverse, sine, cosine, and tangent. So let's look at these very quickly, one at a time. For the inverse sine function, the way that we get this is by taking y equals sine of x and restricting the domain to the closed interval from negative pi halves to pi halves. If we make that restriction, we get a one-to-one function that includes 0, which is always nice. We could have restricted it later, like pi halves to 3 pi halves, but that feels a little bit less sensical. So this was the decision that was made by mathematicians long ago, and those mathematicians are long dead, so we cannot argue with them. We just have to accept it. So by making this restriction, we get a one-to-one function, and then the inverse sine function is simply defined as the inverse function of the sine function restricted to that domain. So we have inverse sine of x equals y whenever sine of y equals x, and y is in between negative pi halves and pi halves. And this is what the graph of the inverse sine function looks like. All right, let's take a look at inverse cosine. Okay, for inverse cosine, we also restrict the domain, and we want to restrict it to a domain that includes 0. So the decision that was made was the closed interval from 0 to pi. That makes it one-to-one. And then if we take the inverse of that, we get a graph that looks like this, and that gives us the inverse cosine function, which is defined by inverse cosine of x equals y, whenever cosine of y equals x, and y is in between 0 and pi. Also remember that we can write this arc cosine instead of inverse cosine, similarly arc sine instead of inverse sine. And then let's quickly look at inverse tangent. To make sure that tangent is one-to-one, we can restrict the domain from negative pi halves to pi halves, not including those numbers because those were not a part of the domain to begin with. This gives us one of the branches of tangent of x. And if we take the inverse of that, that gives us inverse tangent of x equals y, whenever tangent of y equals x, and y is between negative pi halves and pi halves. And when we reflect this graph to get the inverse, we get something like this, which is a little bit different from inverse sine and inverse cosine. With inverse sine and inverse cosine, we have a domain that is just a closed interval, but with inverse tangent, our domain is all real numbers. So it's a little bit different. Now we also have inverse cotangent, inverse secant, and inverse cosecant. These are defined exactly how you would think they are, and the restrictions of the domains align with the restrictions for tangent, cosine, and sine, respectively. But we don't work with these often quite as much, so we're not going to spend much time looking into those now. We really want to focus on inverse sine, inverse cosine, and inverse tangent because those are the ones that come up the most.